Welcome back. In this video we're going to look at double and triple pointers. So before we start, we'll just have a little bit of a recap of what we've done so far. So we can create variables of different types. So for example, I can create car A, I'll give it a value of say 4, and I can make say a short B, and I'll give it the value 8. Now we looked at how we store that in memory. Okay, sorry, it's really bad. So for example, A will take up 1 spot, where B will take up 2 spots, and this will be A, this will be B, and they have the values 4 and 8. We saw another representation, which was the box and pointer diagram. So we have A, which is a car, and it has 4 stored in it, and we have B, which is a short, and it has 8 stored in it. Okay, then we can create some pointers. Now if we want to store the address of A, we're going to need a car star, or a pointer that points at a car. So where you see the star, you can think of it as a pointer that points at a car. But I'm just going to use star because you'll get used to this notation and language soon. So if I want to store the address of A, I need a car star. Now we're assuming 4-byte addresses. Okay. Now, whilst I could possibly store the address of a B inside of a car star, it won't represent the data that it's pointing at correctly. Okay, because a short obviously goes over 2 bytes. So we'll call this pointer 1, and inside of that we can store the address of A. Now this is going to take up 4 spots. Okay, and this will be called pointer 1, and it has the address, so it'll have 0016E566. Now from here we can draw the box and pointer diagram. This diagram here we won't really use except for explanation, where this we'll use quite a lot. So we've got pointer, and we've got car star, and that points at A. Now, a couple of things here. With pointers, unfortunately the compiler sometimes won't tell you, depending on how you've done it, if you've got a problem or not, and rather your program will just crash. So a couple of ways we can check. The left hand side here has a car star, and as I said, an AND adds a star to the type. So this is address of operator. We've got the address of A is a car, the address of adds a star to the type, so we have a car star. So they're both equivalent on the left and right hand side. Another way to check that you're doing this correctly is to have a look at your box and pointer diagrams. The only thing that something should be pointing at is something with 1 less star. So pointer 1 is a car star, so the only thing it should be pointing at is a car. So that's the way we can check the validity there. And I'm just going to add another pointer. Okay. A lot of students get confused by the difference between declaring a pointer. Okay, so at the moment we've declared pointer 2. It's a short star. So after I've used it, I don't add the star. I've declared it. Remember, the type and then a star is just declaration. And if I use the star before now, I'm dereferencing. Okay, so I'm going to where it points to get the value. So I just use pointer 2, and that's referring to this, and I'm going to store the address B. And that's going to point here. Now we can clearly see that pointer 2 is type short star, B is a short, the address of adds a star to the type, so we've got short star and short star. The other way to check is here we've got short star, so that should only point at a short. Okay, so these are the ways that you check that you're doing it right, or else your program will likely crash. And if it doesn't, it may crash later. So remember that we don't get to decide where these things are going in memory. So it might work 10 times out of 100, or it might work 1 time out of 100, or it might work 99 times out of 100. So we don't want any chance that it will crash. Now, the next thing is double pointers. So what if so let me just quickly create our other pointer, pointer 2. So pointer 2 is going to be 0016E56A. This is pointer 2. Now you'll note that these pointers here are holding addresses, and them themselves have addresses as well. So often we want to store the address of a pointer. Now with this, we want to ensure that we're pointing to a pointer that's pointing to the correct type. So if I want to point to this pointer, I need to know that this pointer points to a short. So how I can store my pointer 2 address is going to be, actually I'll do the car first so that everything's in order. How I would store pointer 1's address is going to be car star star, and it can, give it a name, we'll call it pointer 3, and it can store the address of pointer 1. So we create it, once again, it's only 4 bytes of memory, we're only storing an address, and this is going to be pointer 3. So it has the address 0016E56E. Where did I get that from? Right here. I'm not storing the address stored inside the pointer, I'm actually storing the address of the pointer. Now, how do we check that this is valid? Okay, on the left hand side we have car star star. On the right hand side we have a car star, and the address of adds a star to the type, so both sides match, that's perfectly fine. The other way we can check is using our box and pointer diagram. So we have pointer 3, which is a car star star, and that's pointing at pointer 1. Okay? So when you hear pointing at, think holds its address. Once again, the same rule applies with our box and pointer diagrams. Something with car star star should be pointing at something with 1 less star, so that's a car star, so that's valid. We can keep going as many levels as we want, so I could go a car star star, and that would be pointer 4, and that is allowed to store the address of pointer 3. Not pointer 1 and not A, only pointer 3 for a valid pointer. Okay, so you can force it to hold them, and this is why your program crashes, but for a valid pointer it needs to hold that, and that would hold 0016E57A. I got that from here, and once again we could draw that out, and that would be pointer 4 car 3 stars, and that's only allowed to point at something with 1 less star, so we can see that that's valid. Now, what about dereferencing? So with dereferencing, let's say I introduce a new variable called, let's just call it C, and I dereference A. and then I add, oh sorry, not A, pointer 1. I dereference pointer 1, and let's say I add 2. Alright, so let's have a look at this. So pointer 1 is here. Dereferencing will go to where it points and gets the value, okay, if it's on the right hand side. Remember, if it's on the left hand side, we're storing. So it's on the right hand side, so we go to where pointer 1 points, okay, so we just follow the arrow and we get the 4. Okay, and 4 plus 2 gives us 6. So we can look at it this way as well. We've got pointer 1, we dereference, so we go to that address and we get the value of 4. Now, what if I want to use pointer 3 to get that 4? So we can do that as well. So I can go C becomes dereference, pointer 3. Let's say minus 2. So here it gets a little bit more complex, and here is where the box and pointer diagram becomes really, really helpful. So we've got 2 dereferences there. So basically all that means is we follow it once, we follow it twice, and we get our 4. Okay, so we dereference twice, so we follow the arrow twice. Or if you want to think of it in terms of memory, we go to this address, and then we go to this address and get the value. Okay, so we just do it twice. So here we get our 4, and we minus 2, okay, which gives us a 2. So that would put 2 inside of C. Now, how do we check that this is all valid? Remember that adding a star removes a star from the type. So that's when dereferencing. So I'll put that in brackets. So that's when dereferencing, the star removes a star from the type. Okay, we're not declaring here, so we're dereferencing. I'll make that clear that that's 3 stars. Sorry. So here, how do we check that this is valid? So pointer 3 is a car star star. 1 star removes 1 star. The other star removes the other star, so we've got a car. So that's perfectly fine to store in a car. Okay, and also do some maths with. Okay. So this is the way to check everything's valid. This is how you handle double pointers, and this is how you dereference them. If you wanted to do it with a triple pointer, same thing. Pointer 4. Let's just do that. So pointer 4 is up here. We follow the arrow 3 times because we've got 3 dereferences. 1, 2, 3, and we get our 4. So we get a 4. That's a bad color. We get a 4 in here. Now, obviously, if you add too many stars, you're going to crash or get some unexpected result. If you add too few stars, you're going to get a memory address rather than a value, and we'd get something weird in here. Okay, and possibly you might end up crashing your program or ending up with unexpected results. So one last thing we can see is basically what happens if we dereference on the left-hand side with double or triple pointers. So, for example, let's take pointer 3, and we can go star, star, pointer 3, takes the value 21. So here we are not going and getting the value because it's on the left hand side. We're going to store. Where we're going to store this 21 is not in pointer 3, but where pointer 3 points and then what that points at. So we can follow the arrow once again, 1, 2, and we change this 4 into a 21. Okay, So dereferencing on the left and the right hand side still works with double and triple pointers. For most of this lab this week we're only going to see single, but you will see these double pointers very, very soon. We won't really be using triple or anything higher that much in the subject. Alright, so once again this might seem very confusing and we haven't seen quite the power of this yet. We will see some advantages of using pointers in the next couple of videos. We won't see all the advantages in this subject. It is quite a complex topic, but it is the basis of computing and operating systems. And so for someone that's going to be a technology expert or use computers, it is very helpful to know. Alright, that's it. Thank you very much.